So today what we're going to talk about is we're going to talk about measuring variability for skewed distributions, or interquartile range. So they want us to consider the following scenario. A television game show, Fact or Fiction, was canceled after 9 shows. Many people watched the 9 shows and were rather upset when it was taken off the air. A random sample of 80 viewers was selected. Viewers in the sample responded in several questions. The dot plot below shows the distribution of ages of these 80 viewers. So if you look at each dot, each one of these dots in this dot plot represents one person that viewed this show, Fact or Fiction. So they want to know, what does the dot farthest to the left in this dot plot tell us? Well, if we go furthest to the left, that point would be about 5, because it's halfway between 5 and 10. And since there's only one of them, this will tell us that one of the 80 viewers was 5 years old. Okay? And they also want to know, for the second question, is the distribution symmetric? Well, if we look at it, most of our data is to the right. So we know that it's not symmetric. So we're going to say no. And we could say there are more viewers at older ages. So, we know, and since most of our data is to the right, we could say that it's skewed right. So if it's skewed right, that means that the tail is to the left. So, if we look at this, they want to know, what age would you describe a typical age for the sample of viewers? So, if we're looking for this, we're kind of trying to find where our mean is, because our mean will tell us a typical age for the sample of viewers. So if we look at this, we know that ranges from about 0 to 80. So our mean would be probably about the middle, 40. But since it's skewed right, it's going to be pulled kind of to the right. So I would say that it would be somewhere in here. So we're going to say, I would say about 50. Okay, since it's skewed right, it's going to be pulled a little bit to the right. So I'm going to say a typical age of a viewer is about 50 years old. Okay, so now let's ask the next question. It says, a reviewer of this show indicates that it's a cross-generation show. What do you think that means? Well, if we have cross-generational show, we're talking about crossing generations. So I would say that cross-generational show means a show that appeals to a large age range of people. Okay? So, with that in mind, they want to know, does the data set in the dot plot confirm or contradict the idea that it was a cross-generational show? Well, if it appeals to a large age group, we know that there's 5-year-olds that watch it, 6-year-olds, 7-year-olds, 10-year-olds, all the way up until probably 75-ish people. So it does kind of confirm that it is a cross-generational show. So we're going to say yes, because the data shows that it ranges from 5 years old to 75 years old. So there's people all the way in between 5 and 75 years old that like this show. For number 6, they want to know, what could be the reason for the cancellation of this show? Well, if we have a show that has a large range or age range or cross-generational show, we know that with shows, they want to get sponsors to sponsor them so they can make money. Okay? And if they have a large range of data, or a large range of age groups that watch the show, it could be canceled because it's kind of harder to get sponsors because of how large the age range is. So we could say that cross-generational shows are hard to get sponsors. And we could also say, because sponsors like to purchase airtime for shows designed for a target audience. So we could say for shows with a target audience. Okay, so let's continue and move on to the next one. So with the next one, let's turn the page. For exercise 1, they want to know approximately where would you locate the mean or the balance point of the above distribution. But we said that our mean in the last problem, so a typical value, okay, would be about 50 years old. But we can have an estimate, so we could say estimates can be anywhere between 45 to 60 years old. And we said the mean was approximately equal to about 50. Okay? Or you could say, if you didn't want to say 50, you could say anywhere between 45 to 60. But in our case, we use the estimate of 50. For exercise 2, they say, how does the direction of the tail affect the location of the mean age compared to the median age? Okay? So if we have skewed to the right, so we have if we look back at our data set, we have that it's skewed to the right, so the tail is to the left. So if it's skewed right, tail to the left, so let's write that down first. So our data set is skewed right. Okay, so we wrote down that it's skewed to the right and tail to the left. And when it's tail to the left, that means that the mean would be located to the left of the median. So since the tail is to the left, it always tells us that the mean will be to the left of the median. Okay? Exercise 3 says that the mean age of the above sample is approximately 50. So do you think the age describes a typical viewer of the show, and explain your answer? Well, if it describes a typical age, we said that it was 50. Our guess was 50. And we know that that represents a typical age. So we could say that, yes, the typical age of viewers of the show represents the mean. Okay? So if we write that down. So anytime that we know a typical age or a typical data value, that whatever we're talking about, in this case we're talking about age of viewers, but in general, we know that the mean represents a typical age of, or a typical data value of what we're doing. Okay? So now let's look at the exploratory challenge number 2. It says that recall the values of a box plot and what it looks like. So we have our smallest data value is always the farthest to the left. So this data value all the way to the left is going to be our smallest data value. We know that this first bar is represented our quartile 1, or Q1, or the lower quartile. we know that this middle bar is called the median. Okay? That's our middle number. We know that the one above it, the bar that's next to it, so this bar right here, is our quartile 3, or the upper quartile. And then it extends down to our largest value, which is the farthest place we go on this. And we know we want to write down that between our smallest value and our quartile 1, this is represented by 25% of the data. We know that from quartile 1 to the median is represented by 25% of the data. And we know that from our median to our quartile 3, that's also represented by 25% of the data. And then from quartile 3 to the largest value is represented by 25% of the data. So if you look at this, 25, 50, 75, 100. So we know that throughout this whole box plot, from the smallest value to the largest value, will be where 100% of our data is. We know that 25%, or we know that 25 and 25, so in this box that we have, the box represents 50% of the data, because 25% plus 25%. Okay? So now let's look at the next page. Exercise 4. Exercise 4 says we want to use the above dot plot to construct a box plot over the dot plot by completing the following steps. We can locate the middle 40 observations and draw a box around these values. We want to calculate the median and then draw a line in the box in the location of the median. Number 3, we could draw a line that extends from the upper end of the box to the largest observation in the data set. And then we could draw a line that extends from the lower edge of the box plot to the minimum value. Or what we could do, so instead of going through those steps, is we could use our calculator. So that's what I'm going to do. I'm going to use my calculator. So if I'm using my calculator to do this, I'm again going to do it exactly the way we did it in class the other day. So we're going to do stat, edit. And then if there's anything in this list, you're just going to hit clear and then clear out that list. Okay? But I'm not going to clear out this list because I already put in the list earlier. So if we look at this, we're going to go back to that dot plot. So if I go back to that dot plot here, so your list 1 should be blank. But I'm just going to go through, and as I'm going through, I'm just going to put in, so my first value would be 5. Then my next value would be 6. Then it would be 7, so I would just type in 7 and hit enter. So then it would go to 7. Then it jumps up to 10, and there's 3 10s. So I'm going to type in 10 3 times. So 1, 2, 3 10s. Okay? Then there's 111, 112, 113. There's no 14s. There's 2 15s, so I type in 15 twice. 116. Okay? No 17s. 118. No 19s. There's 2 20s. Okay? 121, it jumps all the way up to about 24, so there's 124, 125, 126, so if we look at our values, it should look like this right now. So 126, so I'm going to type in 26 once. There's 127, or no, it goes up to 26. The next value would be 39, then there's no 40, so it's 141. There's 2 42s. Then there's no 43s. There's 2 44s. 145. 2 46s. 147. 148. 149. 150. 151. There's 2 52s. 153. 154, and then it jumps up to about 58. So there's 2 58s, 159, then there's no 60s, then there's 1, 2, 3, 4 61s, so there's 1, 2, 3, 4 61s I would type in. Then there's also 4 62s, so I'm just going through and typing in all 4 of those. Then we have 63, there's 2 of them. Then 64, there's 1, 2, 3, 4. So there's 4 64s. 1, 2, 3, 4. Okay? And then we jump up to 67. There's 2 67s, 2 68s, 2 69s. There's no 70s. So we jump up to 71, and there's 8 of them. So I have 8 71. So 1, 2, 3, 4, 5, 6, 7, 8. Okay? And then 72, there's 1, 2, 3, 4, 5. So there's 5 72s. 1, 2, 3, 4, 5. There's 5 73, so 1, 2, 3, 4, 5. And then there's 2 75s. Okay? And if we look, it says L1 of 80 is 75. So that tells us that we have our data set has 80 values, which we know we have 80 viewers from this. So that would be a good way to check. Okay? So now that I have my list put into my data set, I know I could do this 5-number summary. So I'm going to do this. I'm going to skip to exercise 5 really quick. And we know that we could get our 5-number summary, which we need to make our box plot. So what I'm going to do is I'm going to take my calculator. I know that there are 80 values, so I'm going to write down that there's n is equal to 80. Then I'm going to do stat calculate. I'm going to calculate the one variable statistics of L1. Because I know that I typed in all of my work or all my data values into list 1. So then I'm going to hit enter. And it gives us a bunch of information. It gives me my X bar and all the stuff that I don't need. So I'm going to scroll down to the stuff that I need. So if I scroll down using the down button, I know that n is equal to 80. Our minimum X is 5. So I'm just going to fill in this box plot, or this 5-number summary. So my minimum age is my minimum X, which is 5. My lower quartile, Q1, is 40. I know that my median is 60. I know that my upper quartile is 70. My Q3 is equal to 70. And my max X is 75. So now what I can do is I can use this 5-number summary that I've created, and I could create a box plot. So if I'm going to create a box plot, I first want to find my minimum age. That would be 5. Okay? So I'm going to start at 5. Okay? That is my minimum value. My quartile 1 is 40. So at 40, I'm going to go a little bit above 40, and I'm going to draw a line at 40. My median age is going to be 60, so I'm going to go a little bit above 60 and draw the rest of my box at 60. Then I'm going to go at 70, and then I'm going to go above, and then I'm going to draw my box. Okay? So now what I can do, now that I have those 3 values drawn, is I can create my box. So this is my box that I'm going to draw. Now I'm going to go to my minimum value of 5, so I know that 5 is about halfway between 0 and 10. So at about here, I'm going to draw my dot, and then connect it with a line. And the same thing with 75. So I'm going to go up at 75, draw my line, and there I've just created, there I've just created my box. So basically, just to recap, because it was off camera, we have 40. So I started with my quartile 1, drew my line at 40. So at 40, I just drew a line. Then my median age is 60. So I'm going to just go up to, so since my median age is 60, I'm going to draw my line at 60. Quartile 3, I'm going to draw my age at 70, or my line at 70. And then I could draw my box. Okay? Then I just go, since my minimum value is 5, so I go down to 5, draw my line to it. And then my max age is 75, so at 75 I draw a dot, and then draw my line. Okay? So now what we can do is we can use this box plot to answer some questions. So I'm going to go down to exercise 6. Exercise 6 says, what percent of the data of the box plot capture? So if we're looking at what percent does the box part of the box plot capture, well, we know that between quartile 1, so up here, if we go back to this, so this is quartile 1, this is quartile 3, and we know that between quartile 1 and quartile 3, if we look at what we said before, we know that between quartile 1 and quartile 3 is 25% plus 25%. So if we look at this, which percent of the data does the box part of the box plot capture? It would be 25% plus 25%. So that would equal about 50% of the data. So the box plot represents 20 or 50% of the data. They want to know for exercise 7, what percent of the data falls between the minimum value and quartile 1? Well, we know that between the minimum value, the smallest value, or minimum value, and quartile 1 is 25%. So we know that what percent falls between the minimum value and quartile 1 would be about 25%. So we could say 25% falls between the minimum value and quartile 1. Okay. And then for exercise 8, they want to know what percent of the data falls between quartile 3 and the max value. Well, if we're looking at between quartile 3 and the max value, that would be about 25%. So we know that so I'm going to write down that 25% of the data falls between quartile 3 and the max value. Okay? So, if we go on to the next part for exercise 9 to 13, so they say that an advertising agency researches the ages of viewers most interested in various types of television ads. So consider the following summary. So between ages of 30 to 45, they're interested in electronics, home goods, and cars. Between 46 and 55, they're interested in financial services, appliances, and furniture. Between 56 and 72, they're interested in retirement planning, cruises, healthcare services. So let's look at number 9. Number 9 says that the mean age of the people surveyed is approximately 50 years old. As a result, the producers of the show decided to obtain advertisers for a typical viewer of 50 years old. So according to the table, what products or services do you think the producer will target? Well, if it's 50 is between 46 and 55, so we know that the products that they would like are financial services, appliances, and furniture. Okay. So, the next question, okay. Based on the sample, what percent of people surveyed about fact or fiction could have been interested in these commercials if the advertising table is accurate? Well, if they advertise, so if it's 46 to 55, okay, we know that if we go back to our original dot plot, so if we're looking at 46, so 46 would be, so this is 41, 42, 43, 44, 45. So between 46 here, so this would be 46. And we're going from 46 to 55. So 55 would be 51, 52, 53, 54. So this would be about 55. So between 46 and 55, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 values between 46 and 55. So if we go back to this, we know that 12 out of 80 are in this range. So if we're trying to figure out which percent, we're going to take 12 divided by 80, and if we do that in our calculator here, we could do 12 divided by 80, whoops, it's going to be 0.15, which is equal to about 15%. Because remember, when you go from a decimal to a percent, you just move the decimal point to the right twice. Okay? Now let's look at number 10. Number 10 says the show failed to generate the interest the advertisers hoped. As a result, they stopped advertising on the show, and the show was canceled. Kristen made an argument that a better age to describe the typical viewer is the median age. What is the median age of the sample? In what product or services does the table suggest to viewers if the median age is considered as a description of a typical viewer? Well, we already figured out that the median was equal to 60 years old. Okay? And if the median was 60 years old, 60 would be between 56 and 72. So they would be interested in retirement planning, cruises, healthcare, and healthcare services. Okay? Now for number 11, they want to know what percent of people surveyed would be interested in the products survey suggested by the advertising table if the median age of the viewers. So we want to figure out how many people are between 56 and 72. So now if we go back to our dot plot and we go from 56, so about right next to this, 56 here. So we're going from 56 till about 72, so 71, 72 would be about here. And if we counted them all up, so if we would go through and count up all of the data plots, dot plots, or dots between 56 and 72, we should get that there's 31 of them. So if we go through it, if you want to go through and count them to make sure there's 31, go for it. But number 11, if you count them all up, you'll get that 31 out of 80 people will be surveyed. Okay? So, we'll have 31 divided by 80, which is equal to 0.3875. And if we we move the decimal point over twice and then round, it's going to be approximately equal to 39%. Okay? Because it would be 38.75%, which is about 39%. Okay? Number 12 says, what percent of viewers have ages between quartile 1 and quartile 3? Okay, so we know that between quartile 1 and quartile 3 is 50% of our data. Okay, so which percent of the viewers have ages between quartile 1 and quartile 3? We know that would be 50%. Okay, and they want to know the difference between quartile 1 and quartile 3 and quartile 1. Or quartile 3 minus quartile 1, is called the interquartile range. So interquartile range, or IQR. They want to know, what is the interquartile range of this data set? So we know that quartile 1 is equal to 40, we found out, and quartile 3 is equal to 70. So what we're going to do is we know that the interquartile range, or the IQR, is equal to 70 minus 40. So interquartile just means the difference between the two quartiles. So it would be 70 minus 40, which is equal to 30. So then we're going to have 30 people out of 80, which is equal to 0.375, which is approximately equal to 38%. So we know that 38% of the viewers will be between quartile 1 and quartile 3. Okay, so let's move on. So it says, for number 13, the interquartile range provides a summary of the variability for a skewed distribution. The interquartile range is a number that specifies the length of the intervals that contains the middle half of the ages of viewers. So they want to say, do you think that the producers of the show would prefer a show that has a small or a large interquartile range, and explain? Well, if we have so we can say that a smaller interquartile range, or I'm going to label it IQR, indicates less variability So it may be easier to target advertisements. And these advertisements will be more to a specific age range. So, if it's a specific age range, we know that a larger IQR indicates a large variability. So in this case, in our case here, we have a large IQR because that indicates large variability. And we know that we have a large variability because if we look at even our dot plot here, we know it ranges from 5 to 75. So that's a large range of ages. So we know we have a large variability. So we have a larger interquartile range. Okay? And then it says, do you agree that Kristen's argument that the median provides a better description of a typical viewer? We could say yes, because the median is a better indication of a typical value since the data is skewed. So since the data is skewed, that's what we're going to have. So if the data is skewed, either right or left, it doesn't matter. We know that if it's skewed, that the median is a better indication of a typical value since the data is skewed. Okay? Now let's look at our exploratory challenge 3. The outliers. So now we're going to talk a little bit about outliers. Okay? So basically, it says recall that unusual data values were described as extreme values. Okay? This example provides a more formal definition of an extreme value and shows how extreme values can be displayed in a box plot. Extreme values that fit the definition are called outliers. So that's what we're going to talk about. Outliers. Indication of an extreme value becomes important as students continue to work with box plots. Okay, so as we start working with box plots, we have our, our extreme values. So, exercise 15 to 20. It says, students at Waldo High School are involved in a special project that involves communicating with people in Kenya. Consider a box plot of the ages of 200 randomly selected people from Kenya. So they gave us this dot plot right here. And we're given these values right here. These starred values. So those are still values that were taken from the survey. But it says a data distribution may contain extreme data, specific data values that are unusually large or unusually small relative to the median and the interquartile range. Okay? So a box plot can be used to display extreme data values that are identified as outliers. Okay, so each asterisk that we have here, that's what this symbol is, an asterisk, in the box plot represents the ages of 4 people from the sample. Based on the sample, these 4 ages were considered outliers. So we have 1, 2, 3, 4 ages were considered outliers. So they want us to, if we look at the next page, for the first question, they want us to estimate the values of the 4 ages represented by an asterisk. So if we go back, we could say that if we go straight down here, so I'm just going to draw a line right here, this would be a little bit more than halfway between 60 and 80, so I'm going to say that would be about 72. This one would be a little bit closer, so I'm going to say a little bit closer to 80 would be about 77. I'm going to estimate this third one, if we go down, would be about 82. Okay? And then this last one, if I go down, would be about 100. So I know it's going to be 72, 77, 82, and 100. So I'm going to go through and I'm going to write those estimates down. So you could have different estimates than I did, but I was just estimating. So we have 72, 77, 82, and 100. So it says an outlier is defined to be any data value that is more than 1.5 times whatever our interquartile range is, away from the nearest quartile. They want to know what is the median age of the ages of Kenya, what is the appropriate values of quartile 1 and quartile 3, and what is the approximate interquartile range for the sample. So we need to figure out those three values. So if we go back here, if we look at our data values for our median is right here. So this would be our median. This is our quartile 1, and then this is our quartile 3. So our median value would be a little bit less than 20. So I'm going to estimate the median to be about 18. I'm going to estimate that this quartile 1 will be about 7. In quartile 3, if I go down here, it's a little bit after 30, so I'm going to say 32. So I'm just going to write down those values. So we estimated that our median is equal to 18. Our quartile 1, we said, is equal to 7 years. And then our quartile 3 is equal to 32 years. Okay? So now, since we have those three values, now I can calculate my interquartile range, or my IQR. My interquartile range is my Q3 minus my Q1. So my quartile 3 is 32 minus 7, which will be equal to 25. So I know that my interquartile range is approximately 25. They want us to multiply our interquartile range by 1.5. What value do we get? So we're going to take this 25 and multiply it by 1.5. If you do 25 times 1.5, you'll get 37.5. Okay? And now we want to, it says for 18, now they want us to add this 1.5 times IQR, or this 37.5, add it to our quartile 3. So let's do that. Our quartile 3, so we could say, so we 1.5 times our IQR plus our quartile 3. Well, we know that our 1.5 times IQR is 37.5, so we're going to have 37.5 plus our quartile 3, which is 32. And if we add those together, I'm going to get 69.5. And they say, what do you notice about the four value ages identified in the first example in this 69.5? Well, if we look at this, we have 72, 77, 82, and 100. And we can see that each one of those values is greater than 69.5. So we could say that all values of the outliers are above 69.5. Okay? So that's what makes them outliers, because they're above this 1.5 times IQR. Okay? So they want to know, are there any age values that are less than Q1 minus 1.5 times IQR? Well, we know that our first quartile is 7. So I'm going to do, if I'm doing Q1 minus 1.5, it'll be 7 minus our 1.5 times the IQR is 37.5. So I'm going to do 7 minus 37.5. And if I did 7 minus 37.5, we get a negative 30.5. And we don't have anyone that's lower than negative 30.5. So we're going to say, no, we don't have any values that are below that. So they want to explain why there's no asterisk on the low side of the box plot for the ages of the people in the sample for Kenya. Well, in order for them to be outliers, they'd have to be less than negative 30.5. And in this case, if we're talking about age, you can't be negative age. So we could say that an outlier on the lower end would have to be a negative age, which is not possible. Okay? And that would be the end of the lesson for interquartile range.